All right, hello everyone. I hope you are all doing well. I'll be providing the lecture material for Chapter 8, Bivariate Correlation Research, which goes from pages 203 to 223. And then at the end, I'll also be tying in a portion of Chapter 14 from pages 437 to 443. So to start, we're just going to break down what exactly a bivariate correlation is. So looking at this first word, you can see bi, meaning two, and variate, meaning variable. So two variables, and then correlations, the relationship or association between these two variables. And you can have three different types of associations. You can have a positive association, meaning that an increase in one variable is associated or related to an increase in a second variable. You can have a negative association, meaning that an increase in one variable is associated to a decrease in the second variable, or you can have zero correlation whatsoever. And so this means that as one variable increases, it is not related to an increase or decrease in the second variable. And so the most frequent way that you're going to see bivariate correlations is between two quantitative / continuous variables. And so on the right here, we've got a scatter plot, which depicts the number of hours studied versus test scores. And on the x-axis has the number of hours studied, which can range from 0 to 8. So any given person could have studied anywhere between 0 and 8 hours. And then on the y-axis, you can see we have test scores, which ranges from 0 to 100. So any given person could have scored a 40 or an 80 or a 60 and so on and so forth. And so each of these dots correspond to these two axes. So this hypothetical dot right here, this person studied 2 hours and got roughly a 70% on the exam or the test. And so what you can see from these dots is that there is roughly a up and to the right line that can be drawn between them. And so that's depicting a positive association between these two variables. Somewhat less frequent, you're going to come across a bivariate correlation with one variable that is categorical. And so with this categorical variable, you're going to have two different categories. And so for this hypothetical graph on the right here, we've got average GPA, psych versus non-psych major. And so the category major has two categories, and that is psych major and non-psych major. And then on the x-axis, you can see we have the quantitative / continuous variable, which is GPA, which can range from 0 to 4. And so from looking at these bars, you can see that for psych majors, the average GPA is roughly around 3.6. And then for non-psych majors, you can see that it is roughly around 3.2. And you can, as depicted here, draw a line between these two bars and see the association between the two. So there's a correlation calculated between these two categories. And so one important thing to mention here is that if the categorical variable, the categories within it are not ordered in any significant way, the directionality of the association does not matter. So it doesn't matter if the direction is positive or negative. And so the reason why that is that you could take psych major, this group right here in the categorical variable, and you could put it in place of the non-psych major and the non-psych major here, and you would see that, let's say, the new graph where non-psych majors are on this side, their mean would be here, and then for psych majors, their mean would be here, and you could draw a line between those graphs. And it doesn't matter the order the two categories are in. And so what matters here is ultimately just the strength of the relationship between the two categories, which we will dive into in the next video.